What is a beam? A beam is a structural element that primarily resists loads applied laterally, perpendicular, to its axis. In simple terms, it is a horizontal structural member that supports vertical loads. Beams are fundamental components in structures such as buildings, bridges, and frameworks, where they transfer loads from slabs or roofs to vertical supports like columns or walls. Beams are designed to withstand bending moments, shear forces, and sometimes axial forces. They are made from materials like steel, concrete, wood, or composite materials, depending on the application. Types of beams. Beams can be classified based on different criteria. 1. Based on support conditions. Simply supported beam. Supported at both ends, usually with one pinned and the other on a roller. Example, floor beams in residential buildings. Cantilever beam. Fixed at one end and free at the other. Example, balcony slabs, overhangs. Fixed beam. Both ends are fixed and cannot rotate or translate. Example, rigidly connected beams in frames. Continuous beam. Extends over more than two supports. Example, beams in long-span bridges or multi-span buildings. Overhanging beam. Has one or both ends extending beyond its supports. Example, roof projections or shade slabs. 2. Based on material. Steel beam. Strong and flexible, used in high-rise buildings, industrial structures. Types, I-beam, H-beam, T-beam. Concrete beam. Often reinforced with steel bars, RCC beams, or pre-stressed. Uses, common in residential, commercial, and infrastructure construction. Timber/wooden beam. Traditional use in small-scale or decorative structures. Uses, wooden houses, cottages, old bridges. Composite beam. Made from two or more materials working together, e.g., steel-concrete composite beams. Uses, modern high-rise structures. 3. Based on cross-section. Rectangular beam. Common in RCC constructions. Uses, residential and commercial buildings. T-beam, T-shaped. Used when a slab and beam act together. Uses, concrete floor systems. I-beam. Common in steel construction, efficient in bending. Uses, bridges, multi-story buildings. Circular beam. Used in curved or circular structures. Uses, domes, tanks, circular balconies. Uses of beams. Beams are used in various structural applications. Buildings. To support floors, ceilings, and roofs. To transfer loads from slabs to columns. Bridges. As primary load-carrying members across spans. Industrial structures. To support cranes, machinery, and equipment. Transportation infrastructure. Used in flyovers, elevated roads, and tunnels. Marine and offshore structures. To resist wave, wind, and dynamic forces. Conclusion. Beams are vital structural components used to provide stability and support in construction. Their type, material, and design vary depending on the function and nature of the structure. Understanding different types of beams helps in choosing the right design for safe and cost-effective construction. Beams are structural elements that primarily resist loads applied perpendicular to their longitudinal axis. The behavior and internal forces within a beam depend significantly on its support conditions, which determine how the beam is restrained and how it transfers loads to its supports. Here's an overview of beams based on various support conditions. 1. Simply supported beam. Description: supported at both ends. One end has a hinge, pin, support allowing rotation but no translation, and the other end has a roller support allowing both rotation and horizontal movement. Behavior: can resist vertical loads. Moments are zero at both supports. A bending moment develops along the span, typically with a maximum at midspan under uniform loading. 2. Cantilever beam. Description: fixed at one end and free at the other. Behavior: can resist vertical loads, horizontal loads, and moments. Bending moment and shear force are maximum at the fixed support. Deflects more than simply supported beams under similar loads. Often used in balconies, overhangs, and bridges. 3. Fixed beam. Description: both ends are fixed, meaning no rotation or translation is allowed at the supports. Behavior: can resist vertical loads and end moments. Has higher stiffness compared to simply supported beams. End moments develop due to fixity, reducing midspan moments compared to a simply supported beam. Less deflection under the same load compared to simply supported beams. 4. Continuous beam. Description: a beam that extends over more than two supports. Behavior: has internal supports which induce negative moments at the supports and positive moments in the spans. More efficient load distribution. Requires compatibility of deflection and rotation at intermediate supports. Common in bridges, long span structures, and slabs. 5. Overhanging beam. Description: a simply supported beam with one or both ends extending beyond the supports. Behavior: the overhanging part acts like a cantilever. Creates negative moments at the overhang and positive moments in the span. Useful in balconies or for architectural projections. Comparison table. Type of beam support: condition moment at ends, deflection usage. Simply supported hinge and roller, 0 moderate bridges, floors. Cantilever fixed at one end, non-zero at fixed, high balconies, overhangs. Fixed at both ends, non-zero low industrial structures, heavy machinery. Continuous more than two supports, non-zero, internal, low bridges, long floor spans. Overhanging extends beyond one/both ends, non-zero varies balconies, aesthetic extensions. Conclusion: understanding beams based on their support conditions is essential for predicting how they respond to loads, how they deform, and how internal stresses develop. The choice of support condition directly affects the structural efficiency, cost, and safety of a structure. A simply supported beam is one of the most fundamental structural elements in engineering and mechanics. It is commonly used in construction and mechanical design due to its straightforward behavior and ease of analysis. Definition: a simply supported beam is a structural element that rests on two supports, one at each end, without any moment resistance at the supports. One support is typically a pin support, which allows rotation but not translation, and the other is a roller support, which allows both rotation and horizontal movement. Key characteristics. Support types. Pin support or hinge prevents vertical and horizontal movement, allows rotation. Roller support prevents vertical movement, allows horizontal movement and rotation. Load types. Can carry various loads such as point loads, uniformly distributed loads, UDL, varying distributed loads, moments, internal forces. Shear force and bending moment develop inside the beam depending on the applied loads. Advantages. Simple to construct and analyze. Widely applicable in bridges, floors, and other basic structures. Idealized model for learning structural behavior. Limitations. No moment resistance at the supports. May experience larger deflections compared to fixed beams. Not suitable for very long spans without intermediate supports. Basic analysis example. For a simply supported beam of length L, carrying a point load P at the center. Reactions at supports. Each support carries 2 P. Maximum bending moment. Occurs at the center. Max equals 4 M. Max equals 4. PL. Deflection at the center, for a beam with modulus of elasticity. E and moment of inertia. I. Delta. Max. Equals. 3. 48. Delta. Max. Equals. 48 EI. PL. 3. Applications. Bridge spans. Roof beams. Floor joists. Railway tracks. A cantilever beam is a structural element that is fixed at one end and free at the other. It is widely used in construction and engineering due to its ability to support loads without external bracing or additional support at the free end. Characteristics of a cantilever beam. Support. One end of the beam is rigidly fixed to a wall or column, which resists bending moments and shear forces. Free end. The other end is unsupported and extends beyond the support. Load resistance. It can withstand vertical loads, horizontal forces, and bending moments, making it suitable for overhanging structures. Applications. Bridges, used in cantilever bridges where arms extend from piers and meet in the center. Balconies, support projecting parts of buildings without visible columns beneath. Aircraft wings, serve as structural components that carry loads from the fuselage to the tips. Signboards, often used to support road signs and traffic signals. Advantages. Clear space underneath. No need for support at the far end allows open space beneath. Architectural flexibility. Enables creative and extended designs like overhangs. Structural simplicity. Simplifies support design since only one fixed end is required. Disadvantages. Higher bending moments. The fixed end must resist high stresses, which requires stronger materials or thicker sections. Deflection. The free end may experience noticeable deflection under load. Complex analysis. Structural analysis can be more complex due to asymmetric loading. Bending moment in a cantilever beam. For a point load. P at the free end of a cantilever beam of length. L, the bending moment at a distance. X. X from the free end is X equals minus X. Mx equals minus P, L minus X. At the fixed end, X equals 0. X equals 0, the maximum moment is max equals minus M max equals minus PL. This negative sign indicates the direction of bending, hogging moment.